All right. Okay. So we're 2 minutes in. I don't want to take more time than we need to, but I do want to make sure that we cover a lot of the different impacts of AI operationally within an organization, protection wise, and all of the good stuff. So we're going to get started. Again, thank you all very much for joining. My name is Albert Caballero. I am a field CISO at SentinelOne. And I'm here to bring you, hopefully, some food for thought. There's a few things here that we have discussed in the past. I've given quite a few presentations in the last, it seems, 6 to 12 months on the evolving nature of AI. So some of these things are kind of table stakes now, as opposed to 6 months ago. Other things within this kind of realm of what we're doing is we're trying to understand how to operationalize AI operations inside of our organizations and in not only our detection and response capabilities, but also in how do we maintain these LLMs and these generative AI UIs and manage the new attack surface, right? So we'll talk about that. We'll also talk about Purple AI, of course. And I want to get right into it. We're going to start with AI at SentinelOne, right? Usually this is the last slide, or the slide after this is the last slide, or we talk about it. But, as a security platform and a vendor, it is important to analyze how it is that you're implementing AI across different areas of your platform and therefore of the operations of each of your organizations within your organizations. So as you very well know, or most of you know, if not, many of you will get to know that, the endpoint is a piece of it. The cloud is a big piece of it. Where you store all of this telemetry and data is a piece of it. And in every area, there are different ways to implement AI, and that SentinelOne is implementing AI, right? And this will be the first slide, then we'll get into kind of funner stuff like attacks and LLMs and all that, but table stakes, right? One of the things that is fundamental and that has been happening in the security industry for over a decade now is machine learning and understanding how to classify files and ultimately behaviors as malicious or not malicious, right? Files to features to vectors, that's kind of the AI piece. These deep file inspection, the ML models that we create with all of this training data, that is at the core of what we're doing here, right? That leads into dynamic and behavioral AI, which gets all of these atomic detections and then analyzes them en masse, in group, by chaining them, by understanding their behavior, by understanding what comes first, second, or third. One of the things about static AI or AI in general, is its explainability or lack thereof. And it's something that we're really trying to get after, not only on the generative AI piece, but also on the static AI, where we can give you reasonings behind why any particular engine is detecting a particular behavior or atomic action or file as potentially malicious, right? Of course, there's generative AI, pre-trained AI. This is something that is quite, prevalent in the industry as a whole right now, and in every industry. We have retail vendors putting AI in their apps to help you plan for parties. We also have security vendors leveraging deep knowledge bases of security to help explain, walk through, and automate a lot of the things that would otherwise require quite a bit of programming or syntax querying, knowledge, scripting knowledge that potentially is something that can save us a lot of time in being able to just speak naturally to our SIEM or SOAR or EDR or XDR or whatever platform, security platform as a whole, and be able to get actions in return, parsed queries and actions and alerting and dashboarding information that can be leveraged at scale, right? Potentially, the LLMs, right, are, the next level in what we're trying to deliver. And this is where the operational challenges for any vendor or manufacturer or engineering organization or software development firm or anyone who's integrating AI into their business model needs to be able to understand how they're going to handle things that we'll talk about, like versioning, like the size of their LLM, these things that create challenges, and also how to avoid leaking information, hallucinations, and all of these kind of missteps that could potentially be detrimental to the organization itself, right? And tying it all together, automating responses, enhancing the ability to mitigate, respond in some kind of orchestrated and automated way is potentially the idea. And our storyline, many of you are familiar with the process tree and the EDR capabilities that we have released in our product over time. A lot of these storylines are continuing as our platform evolves to include all of this cloud data and all of this other information. Question is, yes, retrieval augmented languages are similar. There was a question here. The idea between retrieval augmented is that you are grounding the knowledge of your LLM in a security discipline, information security, right? So that when, there's a question, was I attacked by some threat actor, the LLM potentially doesn't think that, were you attacked on the street corner with a knife by an attacker? No, they understand that it's a cybersecurity attack, not potentially a physical attack. And these are things that give it context and personas that can help answer specific to the domain, right? Hopefully that kind of answered the question there. Generative AI and LLMs, right? These are things that give us tremendous gifts. The gifts of generative AI are to be leveraged, but also to be cautious about, right? Allows us to create artifacts of a bunch of different specifications. Incident summaries is part of that, creating something based on, a large body of tasks or actions or text. Potentially, it can give us a quick summary, an intelligent summary that makes sense, hopefully, regarding all of the actions that we're taking over a particular story or incident analysis or workflow or something similar to that. And of course, detection code, right? That's part of what it can create for us that would otherwise take us a lot more time. We know prediction, one of the more basic examples is all, predicting words and phrases as you're typing. Now that seems to be happening everywhere in every chatbot, not just in your Google Drive and your O365, Word docs and in your emails. It's happening everywhere. It is predicting what it is that you're going to type, what it is that you should be doing next, or based on the information it has, what is likely going to be happening next, right? And the idea with leveraging this is to be able to predict attacker activity and where it's going to lead. Right, 9 out of 10 times, these actions led to crypto mining in my EC2 or Docker container, EC2 instance or Docker container, right? So if that happened, 9 out of 10 times, potentially, hopefully, you can get ahead of it next time. And perform a remedial action, right? There. And the interaction is huge. Being able to go back and forth with an engine that understands your security data and is able to then give you some following actions and a step-by-step kind of guidance to allow you to then just create a summary or document your work as you go and hand it off potentially to the next level, or wrap it up in a nice report, right? That's what generative AI gives to us. Some of the other gifts of generative AI are all the challenges that come with running and maintaining these LLMs in our environment. Whether we're leveraging a third party, there's challenges and pitfalls there, or we're sourcing our own data and building our own LLMs and using open source as well as commercial versions to combine and create your own models potentially, or leverage those models in what it is that you're trying to doing, grounded in your data, in the context of the data that you need to analyze and you need to look at. So the challenges, most of you are probably looking at this and saying, oh, well, that's the tip of the iceberg. Yeah, Google challenges with LLMs, you're going to get at least, I think top 20 lists, top 10s, top 15s, top 5s. I felt that I would just pick a few. We can talk about them, understanding there's a lot of other challenges as well and benefits, right? But when you're trying to train and fine tune your LLM, lack of repeatability, right? A lot of times you ask the same question and you get a different response. So how do you test for accuracy there, right? Model transparency is important. Sometimes when you have your closed commercial models that you leverage and you communicate with and you use, that's fine and also good. But, having these open source models out there as well is, I'm going to avoid putting a huge map of all the different LLMs and what year they were, they came into being, all of 90% of which came into being in the last 3 years or something. But having some transparency into what the model is doing is important. Versioning, so OpenAI, let's just, so that hopefully everyone, again, table stakes. There was GPT, there's 3, 3.5, 4, 4.5. There's these models are, you can't just, have your model organically continue to change without having some very strict versioning involved, a path, a transition plan, making sure that these models play nice one version with the other, or how do you try in operations make these updates, right? Hallucinations, everyone, that's probably the one that's most familiar for most. Hallucination happens like a lot. It's some statistics 20-25% of the time. So that's where the retrieval augmented languages, the other type of methods where you can give your LLM a grounding of sorts in a particular discipline with personas, with guardrails that, in this case, we're talking about, right? Security, cybersecurity in general, will help you avoid hallucinations with your LLM. Prompt engineering, it's almost like garbage in, garbage out. Everything changes, but everything stays the same at the same time, right? Ultimately, how good your prompts are going to determine how good your response is and how much you can leverage LLMs in general. And, again, if you're using a commercial LLM, or, who's hosting it, who's providing it, how do you know they're going to do the right thing and keep your data secure, private, and not share too much with the training model moving forward, right? So we'll go a little bit deeper. Some of you may have seen this type of, diagram, maybe not. We've been doing MLOps for a while, machine learning, and understanding how we're versioning and keeping track of our models and implementing that in a static AI type of environment, and how that flows into our behavioral AI engine. But with generative AI, this is obviously something that, has been done maybe for the last year, or has been developing or coming around to being implemented in production over the last year or two. So a big part of this, right? Things like, how big should my model be? The size, LLMs can have millions of parameters and require significant computational power to perform or not, depending on what it is you need to do, right? So how big your data set is, the LLM itself, their models, how big are those? But I mean, how big is your data set? Like, how much data do you actually have to train the model with? And how do you continuously test the model to make sure that it's performing as expected, right? You got to get new data, you got to validate it, you got to retrain the model, you got to do all of these things that require a whole other team, probably a brand new team within your organization, to be able to create workflows for that are going to produce stable and repeatable and scalable implementations of whatever it is, of whatever software, app, platform, tool that it is that you're implementing moving forward, or thinking of implementing moving forward. Either you host it yourself, is it open source, etc. All of these questions are more gifts. The generative AI, the gift that gives on, that keeps on giving, right? Probably more challenges than gifts at this time, but ultimately the train has left the station, right? So the train has left the station, everyone is on it, and we're gonna have to figure out how to best protect this new attack surface that exists, right? So if you're implementing AI within your product, within your processes, as a business or as an organization, and LLMs are a thing, if your solution as a business, if your product or service leverages AI, and you are developing and you have AI engineers and data scientists on staff, there is a new attack surface, right? Everything that applies to any other attack surface applies to the operational environment and surface and architecture of whatever AI implementation you're working with. So people will recon, right? They have to gain initial access. How do they do that? Do they do that via the supply chain? Do they do that via evasion? Do they scan public facing? They will be scanning. They are scanning public facing endpoints to your LLM APIs right now, right? So these things are happening, and we need to also understand whatever it is that we're running. Obviously, this is not exclusive to AI. I just feel like needs to be, it shouldn't be left unsaid that it applies to AI. It's inclusive, obviously, right? So, an exfiltration impact. MITRE is actually now, giving us also some mitigations. So, these are things that hopefully, all of our vulnerability platforms will start getting on the bandwagon as well, and being able to deliver attack surface management of our new AI attack surface. So this slide, every time I take it off, I put it back on because it's just cool, and examples of things that can leverage AI. I'm sure we could talk about deep fakes and other things like that, but here's the thing: when you have a perfect example of some malware that tries to act benign, runs benign on your system, benign executables or binaries on your system, then reaches out to ChatGPT or whatever generative AI endpoint or API is available to whatever the backend LLM and transformer architecture looks like, and is able to dynamically generate code and deliver unique malware payloads. That's okay. Well, that's something to pay attention to, right? That's something that has been proof of concepted, and it has been successfully launched, right? So DeepLocker is, pretty cool. It's more of a trigger mechanism than it is the malware itself, right? But I think it's cool because it's like the old school logic bombs, right? I'm a database administrator, and I know I'm getting fired, or I give my 2 weeks notice, and I said some malware to go off, 30 days after I leave the company, and delete all the backups, right? That's what they do. I was going to say we did. No, they do in the 90s and in the 2000s. And these are things that, we were introduced to early on, these concepts. But now we have obviously more sophisticated trigger mechanisms like facial and voice recognition, right? So when this person stands in front of the camera, perform these actions, whatever those actions are. Those actions could be, anything, whatever your creative automation juices decide tell you to do, right? And then we hear, and we'll talk about GANs or generative adversarial networks in a minute. But the whole idea here is to bypass machine learning detections. Static detections are atomic. They're kind of a point in time. They can analyze a whole lot of things, but what they can't analyze is things over time, right? And that's where your behavioral kind of detections and sensors and protection mechanisms really start coming into play and start becoming more valuable. That being said, the first thing you got to bypass is, the machine learning static AI detection mechanism of, any endpoint tool, right? So these are things that happen via generative adversarial networks. Now, GANs are not good or bad, right? They, like every technology, determines what it is that you're trying to do, and whether the results are ethical or for the greater good, or perhaps not. We have seen malware that goes ahead and runs malware code through a black box static AI detection engine, meaning could be any commercial off-the-shelf EPP or EDR or security or antivirus agent of any kind, runs it. And if it detects it, it will learn, it'll try again, and it will learn, it'll try again, until it finds something that particular agent does not detect as malicious. And there's your code, right? And really, That's all it is. It's actually a very easy concept. The generator generates a sample, the discriminator decides bad or good. If it's the result you're looking for, great. If it's not, try again. And that's how we have some of the like GAN type, pass GAN, mal GAN type stuff. We know spear phishing. I won't go over all of these. You guys have probably already read them as I've been talking. These are all things that are extremely prevalent in how attackers are weaponizing these AI frameworks. This is another cool slide. We'll get to the new stuff soon. But I mean, how can you not like talking about digital twins though, right? You know, digital twins are literally copies. So, you know, I'm going to be also presenting specifically on AI in healthcare and in other and in the financial sector and so forth. But specifically, digital twins are fascinating in the healthcare realm right now, for me, because all of the potential that has for good, for benefit, is tremendous. But then it's also quite scary, the type of simulations, the type of tests that can occur on a digital twin. Also, digital twins on the financial side are pretty scary because you create basically another you or identity that is you, but not, right? That's digital. And then potentially live an entire life for that persona, for that digital twin that could lead to things in the real world, that could lead to adversarial, nefarious activities in the real world. We know cyber physical systems, speaking of the real world, right? Take over a smart factory, lose lives. That kind of thing is ultimately, possible, but we couldn't be where we are today without them. Gun detection, really cool. Any closed caption or closed circuit recorder you can just run AI gun detection software and then autonomous weapons. We know about that. We won't even get into the whole geopolitical situation right now. I'm going to avoid that topic on this webinar for sure. So how do we build better defenses system-wide with or by leveraging AI? Well, again, it's everything that we're already doing, right? It's not going to be a unique, siloed thing, much like security, right? Security, we say, secure by design, secure from the start. Start bringing security into the SDLC as early as possible, right? Same thing with potential available AI, right? Cloud providers are huge in the effort of delivering AI-based capabilities across the board, right? The big four. And yeah, I mean, I'm adding IBM as AWS and Google, Azure. And I threw in there just because Watson's a thing. But, all of these cloud providers are giving significant capabilities to build your own models, train them, purpose-built silicon in AWS that is optimized for machine learning type instances. These things are out there and they are getting cooler and cooler. So now that we have AI, why can't we just automate everything? Yeah, well, let's automate everything, right? Anywhere there's a script, there can be AI. There may not be a tool right now that allows you to implement it in that way, but understanding what tasks take the most time and understanding what tools or platforms that are being built or that have a vision or that exist today that are moving in that direction early on can be the difference between a competitive advantage in the years to come, right? Your organization, your business will not continue to gain market share, stability, resilience, if in some way you're not leveraging these capabilities. You're going to fall behind. We hope we can secure more. We hope we can secure more with these new AI security tools and technologies. We're certainly implementing, and we were off to the races, slide one, right? We're certainly implementing AI in every aspect and way that we feel is effective to be able to further the cause here, right? Been doing it for more than a decade, right? Ultimately, pioneering AI is something that, you know, has been an organizational directive of ours and should and could be of any organization or security organization. Analyze everything. So this reminds, you know, what does an incident handler always want more of, right? Information. You know, the more you know, the more you know. So if you can analyze more data, first of all, there's so much data being generated today that I don't see how we could potentially have ever made progress on that without some of the advents that we're seeing here, not just in learning models and data models and generative AI, but also in back-end data scalability, as well as cloud scalability, right? Being able to compute, data storage, scalable exponentially as we need it or as our pockets will allow, as we can afford it. It's there. So how much do we need? Obviously, that's going. Everyone's going to have a different answer to that, right? And of course, we want to improve user experience. Every organization now has a chat bot or automated AI-based email response systems, customer service, phone. I mean, you know, customer experience, right? Improve experience. And that customer is not necessarily someone, you know, a hotel visitor checking into a hotel chain. It could very well be a SOC analyst, because you're, you know, kind of my background, platform engineering, you know, an architecture guy. So if we're gonna build a platform, whatever, a SIM platform, vulnerability management platform, risk management, GRC tool, whatever platform you're building, you have a customer. And the experience of that customer, if for the SOC, every time there's a case that fires off, you want to make sure a Slack channel is created so that you can handle it and it's associated with your case and you can collaborate, and then you have some automation going somewhere else. These types of things are certainly considerations that AI could definitely help you leap forward in being able to deliver these types of things across your organization, right? All right, so this is a throwback as well. Some of you may or may not have kind of heard my take on this one. But, okay, so if we don't have intelligent automation, then what are we all doing here, right? This is, I think, the number kind of one thing. So table stakes. So this used to sound good, but this is like, okay, got to have the ability to automate responses, mitigations, be able to extract and correlate IOCs, threat intelligence, do something with that, so that you can hunt, you know, not just dedicated threat hunting where you're going back 30 days or something and trying to figure out if something has happened, but I mean, in the hunt, when you're responding, right? You need to be able to do this quickly as you're handling an investigation, hopefully something that's not too ubiquitous or too, kind of out there yet, spread too far yet. And behavioral anomaly detection, these kinds of things, with a precision approach, right? So, accuracy, so it's a machine learning kind of concept, right? Where, it's kind of a combination of precision. So how often you are correct with predicting what it is that you are supposed to be predicting, right? And then there's another factor called recall, right? That shows, are you finding all of the objects that have this particular, that you are correct about? These things, precision and recall, kind of, you got to balance these. I would argue that we need to be precise, more so. Precision is kind of a little bit, on the more important side, because we already have, dare I say it, alert fatigue. We have things that look malicious but are benign. We have administrators all the time doing things that really appear to be exactly the same thing as what an attacker would do, and vice versa, living off the land. So, we want to be as precise and as accurate as possible. And then, area defense. So usually Skynet is like on my villain slide, right? It's on my attacks slide. But, I figured I'd change it up. It was designed, right, as a defense system. A defense system that was hooked into everything. System-wide resilience, literally the slide I just presented on. Automate everything, right? Build everything better, AI across the board. What could go wrong? What could go wrong? I'll leave that up to everyone here to answer for themselves. But that's what that's what we're talking about. So hopefully the keys to the kingdom there don't get put into the wrong hands. So how do we fight AI with AI? Again, okay, there's a million ways, right? I feel like these are some of the things that we're doing right now, and that in the immediate future need to start happening, like now, right? Of course, malware detection, table stakes, breach risk prediction, a little bit, not yet, but we do have attack path simulations. There's plenty of platforms and tools out there that can not only show you you're vulnerable, maybe show you when you're being attacked, but also actively look for a way to attack you in a vulnerable place and show you what that path is. Now, I don't know if it can actively show you where someone is today, right now, on that path, but I believe we need to get there, right? And ultimately, we need to be able to stop that type of stuff with accuracy, with a high level of accuracy. Of course, we can prioritize critical defenses, right? Of course, we can see what is dependent on what is vulnerable, what is exposed to the internet. Obviously, we need to be able to, dare I say it, risk score a potential threat, vulnerability, attack vector. These things, we need to be able to map them out, and we need to be able to, get ahead of that game. Correlating attack patterns, kind of in line with that. you know, I don't want to dwell on most of these, or every single one of them, I should say. But these are all things that need to happen, are happening, and we're finding better ways of being able to do this without someone having to know up front what it is that they're looking for and what it is that what action they want to take when they find it. Right? That's kind of the idea there. So let's talk a little bit about Purple AI. Many of you have heard of it. We kind of announced it late last quarter of last year. This quarter, we're going live with it. This is something that, we feel can truly elevate the operations of most security organizations. We want to empower. So, I remember implementing SIMs. I mean, before they were called SIMs, right? Been using probably the biggest SIM out there since it was free. So quite familiar with the industry. And I'll tell you, if I didn't have to learn how to query, learn regex, learn how to parse events, manually, I would have taken a whole lot more vacations. I would have slept a whole lot more 8-hour nights. This is something that I think rubber meets the road is really going to help analysts be able to, and not just, anybody who touches the platform, especially more experienced security engineers and analysts, I think are going to gain the most benefit from this type of capability, right? Because, you all know what it is that you need done. And sometimes the level 1 or even level 2 analysts are gathering information and escalating if there's a clear problem, which they can clearly see. But, doing the more proactive, maybe complex dashboarding, monitoring, and SOAR and detection engineering is something that, there's another team for, or there's an L3 or an escalation, right? That they can leverage. You want to accelerate threat hunting in every way you can. So to be able to get auto summaries and queries and things like that, just help reduce time, right? And the workflow is really cool. The workflow is something that, when you're doing triage and you're doing analysis and you're taking steps and you're documenting, maybe you're doing some query in these other logs or doing something else, and you want to bring someone else to either collaborate or to take the investigation further, and you want to escalate it, being able to save that, pass it on, also to auto-generate a timeline, be able to generate a report from it. These are things that we are working on delivering and will continue to be using as our North Stars, right? So a couple of questions. Absolutely. I think there's definitely a recording that will be available after this for everyone. I do not know if an actual deck, but reach out and I can get you whatever information it is that you're looking for. But I'm pretty sure that, the recording will be available. So to talk about our reference architecture, I feel like some of these presentations may not be very product specific, but I wanted to go ahead and just use our point of view to deliver what it is that the methodology behind the idea of what we're implementing here. And these are all concepts we already spoke about, right? We've got our backend, the data lake, which is nice. I mean, the performance is pretty undeniable. So we are migrating as an organization to running that for the backend, everybody's backend, the S1, EPP, EDR, XDR, data lake, all of it, right? It's just, listen, it works well, scalable, it does what we need it to do at the petabyte scale. I mean, we're good. So next comes the knowledge. We do have a couple billion data points and things that the knowledge is important, the knowledge base, that is LLM ops, right? It's something we need to consider. We need to continue to update, to have as much content as possible made available in there, including our threat feeds, right? Any additional sources. We have the Watchtower threat hunting team. We actually do what we're trying to do monthly, a webcast regarding threat hunter insights into particular threat actors. We release monthly reports, end of year reports. We also have that Mandiant Threat Intel OEM integration. So obviously we need to leverage that threat intelligence. Our statistical models are important. They're there. They're plentiful. A lot of decision tree action going on there, XGBoost, this type of functionality. It's what we've been doing for 10 years. And the LLM, right? And this LLM architecture needs to be dynamic, needs to be swappable, needs to type versioning, and grounded in security information. This is the legal slide. No one made me put this slide in the presentation. I felt, we were talking about ethical AI, and I digged up this from one of our other VP's decks, and I felt like, listen, why not just come out and really just speak to the importance. And yes, it's an all text slide. I don't like those either. But if you're going to read any slide, you got to read the disclaimer. And this is it, right? The idea here is for us to maintain. So we've always had a very scalable platform, multi-tenancy, role-based access is extremely granular. During my experience running a very large implementation, or a team of guys running a very large implementation of SentinelOne, we used it not only for our own security department, but we felt comfortable enough to open it to our IT owners and system administrators, computer admins, and give them role-based access to their systems in their site, in their groups, and so forth. And, it's something that is by design, goes all the way up throughout the entire architecture. Excuse me. So the same concept here. We don't want to improve any other third-party sources. You're not going to get the we're collecting your data thing. We're not going to retain your thing. That is not our thing, right? It's not what we're doing here. This is also, I felt it's become almost mandatory slide. You have to move forward and think, okay, what decisions do I leave up to us? And what decisions can a machine perform? And where does one of them give way to the other, right? That quote from a French pilot and writer, I don't even know where I got that from, but I think, it was funny. I had a colleague that was like, oh, I had to read that book in high school. I'm like, how that? But listen, it's true, right? The machine does not isolate us from these problems, dives us straight into it, right? So how deep do we want the machine to go before we say, okay, we're taking over? Now, obviously, these cognitive workloads, that's where they work the best. Pattern identification, analysis, creating even hypotheses, summarizing stuff for us, read these 5 law books and tell me which case, is most likely to apply. or give me the top 10 cases that I need to read, right? Beautiful. But then we cannot expect the machine to have intuition, to understand the full context of what's happening in the real world, right? The ethics to guide it in every case, and then ultimately, only we know strategically what it is that we need to do, right? So we need to guide this process. And that's kind of, most of my colleagues put human plus machine, right? Human versus machine, I guess that's, semantics. It could go either way, right? I feel like, it could be versus or plus. I got another question here. Adapt to evolving patterns of advanced phishing attacks. Like how do we, and adversarial AI? Well, it's a lot of data and a lot of learning. Our decision trees continue to get bigger. Our models and our algorithms continue to get better. This is evolving, ever evolving, right? And the more information that we have, the better decisions we continue to make. So, these tactics, the data models don't change necessarily that often. I mean, when you've decided on an algorithm or a data model that works well, you double down and you continue to use it, right? So when we talk about what is next, the idea of predictive analytics, automated incident response, and adversarial AI defense, I could list 10 more things here. Privacy preserving, explainable AI that we spoke about, autonomous systems. I feel like there's at least a dozen categories that the what's next question applies. When it comes to information security or cybersecurity, these are the kind of things. I got a couple more. Let me see another question. Could you elaborate on the model's training process, feature selection and anomaly detection, and generalized from the past some of the stuff you could predict as you couldn't predict as unseen vectors? So, that's a great question that I think might be just a little bit beyond the scope here, but we dive deeper into our static detections and our behavioral detections, the IOCs, and the threat hunting involved in that, and how those come along, how those chain in our Threat Hunter webcast. So shameless plug, check it out. I'm sure you can register and get the recording of the last 3 episodes that we've had, where the model, the static AI detection, does detect something, but that doesn't, even if it detects it as malicious, that's not necessarily the final verdict, right? It moves into the behavioral AI engine, then reputational engine, not reputational AI, just reputational engine. Then, so there's an alert flow that every detection goes through before a decision is actually made. And the combination of these chained detections or actions is what ultimately, let me go back, what ultimately helps us prevent new and unseen attack vectors, right? Hopefully that got to the root of the question that you were asking. And you guys are free to ping me on LinkedIn or whatever, however you can get in communications, ask further questions as well afterwards, because this is a blast. Love talking about this stuff. Let me see if I think I'm here approaching the end. Last slide. Ultimately, and I also get debate, should I just put 2 or 3 things or 10 things? What are the key takeaways? I settled on 5 this time. I think last time it was 3. Next time it'll probably be 10. I don't know. So obviously immense potential for attacking. Hopefully it significantly enhances our cybersecurity, right? holistic approach, defensive AI, and for the sake of everything that's good, collaboration, right, is vital. It can't just be commercial, you know, tools that are black box that lock you in, that determine how it is that you evolve in your AI journey, but also open source efforts and collaboration between the community is what's going to get us there, right? So, with that said, I really appreciate everyone's time. I think we kept it to right around, I actually wanted to end sooner, but I knew we wouldn't. So hopefully we've covered all of the information. It was valuable. It was useful to everyone that has joined. And again, I deeply appreciate everyone sticking around and joining us today. So thank you very much.